All right, recording in progress. Right here. So let's share the screen. All right, so we're continuing on with 1.6, and I'll give you your second quiz shortly. So next week, 1.7, 1.8, and our first exam. Okay, so we have already had one quiz, so you know how the quizzes work. Do the work. It's due at 11:59 p.m. tonight. Just take a picture on your cell phone, click, 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 or scan it, and then email to me by 11:59. Okay, next week will be our first test. I'll talk more about it when we get there. And again, for the exams, that's the time you have to synchronously show up in class. So you can't just watch the video or anything. So you need to show up. I will take attendance, have your camera on, true background. Don't have like Golden Gate Bridge or whatever. And you have to submit the homework also. So what do you submit? Everything over here. Guess over here now. Okay. So that's that. So I'll be doing a lot more problems from 1.6, but let me first give you the quiz. All right, so for those of you that are here with me synchronously right now, about 9:11 or 9:12, get your cell phones out or get ready to do a screenshot. If you're watching the video later, of course, you can just watch the video. And here we go. So I'm going to hold it here for maybe 15 seconds. So do a screenshot or take a picture on your cell phone. Number one, find the standard form of the circle with center -3, 5, and radius 7. Just plug right into the formula. I can't write it right now, but I can even tell you. It's going to be the one that goes x minus h squared plus y minus k squared equals r squared, right? We did a problem just like that. 2, determine whether the point A, 4, -3, or B, -5, 1 is closer to the origin. Which one is closer to the origin? There's a problem exactly like that in the homework, right? Find out how far A is from 0, 0, how far B is from 0, 0, and whichever is the smaller number will be the answer, right? And number 3, determine which symmetries are exhibited by the graph of y equals 1 over x. Okay, so do the complete analysis. I can't write it, but you can look it up. So remember, for x-axis symmetry, you replace y with -y and see, do you get an equivalent equation? Okay, and for y-axis symmetry, you replace x with -x and see if you get an equivalent equation. And then for origin symmetry, you do both of them. So for number 3, you have to do all those analyses. Okay, so origin symmetry, replace x with -x and y with -y, and you get an equivalent equation. Okay, so I'm practically telling you what to do for all of them. Number 1, look up the formula for the equation of a circle, and you pretty much just plug it in. 2, check the homework, and I think we did something like that in class. Which one is closer to the origin? And number 3, does it have x-axis symmetry, y-axis symmetry, or origin symmetry? X-axis symmetry, replace y with -y to get an equivalent equation. Right? Replace x with -x to see if you have y-axis symmetry, and do both of them. Replace x with -x and y with -y, and you get an equivalent equation for origin symmetry. You don't actually have to graph it if you don't want to. You may if it helps you, but no need there. Okay, that's the quiz. Do 11:59 p.m. tonight. So that's what, more than half a day. Unless you're watching the video. Those of you watching the video, you get a little bit less time, but you still should have plenty of time. Even if you get it at 2 or 3 o'clock this afternoon, you still have lots of time to do the quiz. Okay. Any quick questions about the quiz? All right, so I'm going to spend the rest of today doing a whole bunch of problems from 1.6. So trying to get you a lot of this. So here's the assignment, but I'm going to end up doing a whole bunch of them anyway. Okay, so here comes a whole bunch of them. Okay, problem 27. So I'm trying to show you at least one of each type of problem. Ask for the domain of each function. I was going to do C and D because those are the hardest. I'll just mention quickly in passing 27A, 2 minus x. You're allowed to plug in any real number for that. Okay, so the domain is simply all real numbers. In fact, I'll just write the answer, all real numbers. B looks like the same thing, except the 2 minus x is in the bottom. Well, I know I cannot divide by 2. I cannot divide by 0. So what number would give me a 0 in the bottom? That would be 2. So you want to say all real numbers except for 2. Here's the way you write it. Funny looking arm minus the set consisting of 2. So that would be the domain. Okay. You could also write negative infinity 2 and union 2 infinity. I'm not even going to write it. That's so clumsy. It's a lot easier to just write it like this. All real numbers except for 2. So this domain is all real numbers. There's no trouble spot for x. You're not dividing by anything. You're not taking the square root of anything. All real numbers. Here, the extra thing is you cannot divide by 0. What number gives me a 0 in the bottom? 2. So the domain is all real numbers besides 2.
So the set, when you set number 2 in brackets, does it mean that all real numbers minus 2?
All real numbers except for 2. Don't include 2. So you have shaded the whole real number line, except there's a dot, open circle at 2. Okay.
Okay. But you do the minus bracket, square bracket to square, close a square bracket?
You cannot use brackets, yeah, because bracket means an interval. That already has a meaning. So you must not
curly braces. Curly braces.
It's got to be braces.
Yeah.
Okay.
But you do minus before the curly braces?
Minus sign, yes. That's a minus. It means throwing out that set. You're not subtracting numbers, but throwing something out of a set.
Got it. Thank you.
All right, welcome. These two, a little bit tougher because of the square root. So, but here's the way you want to analyze it. Here's C. I've got square root of something. Okay, for real numbers, the thing behind my finger has to be greater than or equal to 0, right? I cannot take the square root of a negative. I can take the square root of a positive. I can take the square root of 0. So the thing behind my finger, 2 minus x, greater than or equal to 0. That's what I want to solve. Then I add x to both sides. 2 is greater than or equal to x, or writing the same thing with the variable on the left. We're used to having the variable on the left side. X is less than or equal to 2. So that makes a domain from negative infinity to 2 bracket. Okay. All the numbers that are less than or equal to 2, negative infinity, comma, 2 bracket. Okay. And then what's the difference between C and D? That's a D there for domain. D for domain. The only difference between this one and this one is that now the square root is in the denominator. So your analysis for C and D is exactly the same, except here 2 is allowed. Here 2 is not allowed because you'll be getting a 0 in the bottom. And you're not allowed to divide by 0. So for 27D as in dog, negative infinity 2 parenthesis. Because over here, 2 is okay. I'm allowed to plug in 2 here. 2 minus 2 is 0, square root of 0 is 0. But I'm not allowed to plug in 2 here, parenthesis. So that's the big difference for that one. Okay. And I was going to show you 31B. So all of these are kind of similar. You do have to watch out for the square roots there. So I'll do B, square root of x times 2 minus x. The basic idea, again, is still whatever's underneath the square root has to be greater than or equal to 0. So 31B, as in boy, square root of x times 2 minus x. So again, whatever's behind my finger, greater than or equal to 0. Not negative, non-negative, positive, or 0. And we've already done problems like this, right? Which is the reason why we spent all that time setting up problems like this before. How do I solve this? X times 2 minus x greater than or equal to 0. So I make my sign chart again, right? What number makes this 0? Well, 0. What number makes this 0? 2. 0 and 2. Closed circle because I have the line underneath it. If I plug in 0 here and a 0 here, it would say 0 times whatever this is, greater than or equal to 0. That's true. And likewise, if I plug in 2, right? Put a 2 right here and a 2 right here. Well, this says 2 minus 2 is 0. 0 times that is 0. 0 is greater than or equal to 0. True. Then I do my sign chart. So pick something in region 1, region 2, region 3. Region 1, -1. Region 2, 1. Region 3, 3. Plug in -1 is negative. 2 minus a -1 is positive. So I have a negative times a positive. That's a negative. Negative greater than or equal to 0. No, that's false. Don't shade that in. Region 2, plug in 1. 1, positive. 2 minus 1, positive. Positive times positive is positive. Positive greater than or equal to 0, true. Shade in. Region 3, 3, positive. 2 minus 3, negative. Positive times a negative, negative. Is a negative greater than or equal to 0? No, that's false. Do not shade that in. So I just shade in region 2 and the endpoint. So the domain is bracket 0, 2, bracket. All right, yeah, I want to go way back to this one here. So quick reminder from algebra. If you have x equals a constant, like x equals 2, x equals -5, that's a vertical line. If all you see is y equals a number, y equals -5, y equals 21, those are horizontal lines, like that. All right, I'm going to go back. Okay, we did some of these problems already about is it a function or is it not a function? But there are some problems, whoops. Some problems involving domain and range. Okay, so domain and range for number 12. Okay, domain. So how far to the left and to the right? It looks like I have all the real numbers except there's nothing at -4 and there's nothing at 4. So when they write it like that, you assume you get really, 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 really close to -4. All the numbers right up to -4, but not -4 itself. And not 4 here either. So the way I like to write it is all real numbers minus the set consisting of -4 and 4. That's sort of like what I did over here with the throwing out, right? All real numbers except for 2, throw out 2. So all real numbers except for -4 and 4. Now, you can write it like this. I think the back of the book does this. I don't prefer it, but if you stop and think about the number line, right? This is -4. It's +4. Open circle, shade, shade, shade. This says -infinity to -4. That's that. Union -4 to 4. Union 4 to infinity. Which is true, but that's very clumsy in my opinion. It's a lot easier to just say this. Give me all the real numbers, throw out -4, throw out 4. So I actually prefer this. This is much more clumsy. For the range, how to get that range? So range is up and down. So I got 0 and all the way down. So that's -infinity to 0, count to 0, so bracket. Union Okay, this is 2. You don't quite touch 2. You get really, 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 really close to 2, like 2.0001, but not quite 2. And it looks like it shoots up. So parenthesis, negative infinity, 0, bracket, union 2 to infinity. Don't count the 2 to infinity. Okay, so one more time. I'm not sure I can show you both at the same time. I fold the paper a little bit, maybe. Yeah. So negative infinity to 0, include the 0, union 2 to infinity. So range is for y. Okay, then I'll show you 14. Domain. Well, you go all the way to the left. Looks like you go right up to 2, but don't include 2. So the domain is negative infinity to 2, like so. You're going all the way to the left. You don't quite reach 2. You get 1.999999999, but not 2. So the domain is parenthesis negative infinity to 2 parenthesis. Range, you don't quite touch 0. You do get 0.0001, and then everything above that. So the range is parenthesis 0, comma, infinity. It goes all the way up for that one. Okay. Right, so that's the way that one goes. Okay, let me go on and do a lot more problems. 23, what are they talking about? Determine a number a in the domain of the function with f of a equal b for the given value of b. Basically saying, let this equal this. Let x squared minus 1 equal 0. F of x equals x squared minus 1. B equals 0. It really means let y equals 0. We're just saying it in a very convoluted way. So 0 is the b. 0 equals x squared plus 1. Add 1. 1 equals x squared. Do the square root property, include a plus or minus. So x is plus or minus 1. Or they're saying a is plus or minus 1. They're telling you for a particular value of x, which is a. So the final answer is a is plus or minus 1, officially.
So why the b equals 0 then?
B equals 0, they gave it to me. They said just plug it in.
Oh, that's what is given, which is in place of x then.
The b is in place of the y, actually. Is what they mean there. F of a equals b. B is a y value.
Okay, got it,
Okay.
yes.
Right? Sure.
Yes.
Okay, and then how do you do something like 33? So I'll show you those. They're asking me all this stuff. So f of x is x squared plus 2. What's that and that and that, blah, 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 blah. Okay, so I'll show you 33. X squared plus 2. So f of negative x means put negative x right there. So parentheses negative x squared plus 2. But what's negative x squared? Negative x times negative x. Well, it's the same thing as x squared. So it's x squared plus 2. Okay. And incidentally, side note, it's the same as the original, which means this would qualify as an even function. Okay. And even more of a side note, the exponent is 2, which is an even number. Okay, then they're asking me all this stuff, right? Negative f of x, so I'm trying to show you all of this. Negative f of x means just give me the opposite of this. The opposite of x squared plus 2 is negative x squared minus 2. Okay, then they ask me for f of 1 over x. That means right here, pretend you erase it. I cover it up with my pen. Put parentheses 1 over x. 1 over x squared plus 2. 1 over x squared, 1 over x times 1 over x, is 1 over x squared. So 1 over x squared plus 2. Then it asks for 1 over f of x. So I just go 1 divided by that whole thing. 1 divided by x squared plus 2. And just leave it like that. Then f of radical x. F of radical, so right here, pretend you were raised to x, put square root of x. So f of radical x is square root of x squared plus 2. But what happens when you have a square root squared? Just x plus 2. And finally, square root of f of x, just give me the square root of this whole thing, right? So I radical that whole thing. So there it is, square root of x squared plus 2. All right, so that's the way that one works. Okay, then some harder problems here. 37 to 48. I want you to find all this stuff. F of x plus h, f of x plus h minus f of x plus h minus f of x all over h, where h is not equal to 0. And the value of f of x minus plus h minus f of x all over h, what does that approach as h approaches 0? Okay, this is a setup for calculus. Okay, so I'm just letting you know ahead of time. Say, man, I'm looking at all this weird stuff. I'm glad I don't have to worry about it after this. No, we're getting you set up for calculus. You're going to see this expression quite a bit in calculus.
Is that
I'm not
because
trying to scare you overly, but just reality. Okay, you're going to see that in calculus. Yeah, question?
Yeah, so this formula is applied to limits, right, in calculus?
This is limits, which is what approaches is. Yeah, we'll get to that.
Yeah.
Okay, I'm going to tell you what. I'm going to jump straight to C, because if I do C, I'm really doing A and B, am I not? Take a look. If I just go straight to C, C has that, and C has that. Okay, so I'm going to start with C, so to speak. I'm going to do f of x plus h minus f of x all over h. Okay, so 37 is 3x minus 2. So this is letter C, f of x plus h minus f of x. Okay. Well, let me get this out of the way. Minus the original f of x means minus parentheses 3x minus 2, right? This is f of x. So blah, 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 minus 3x minus 2. That's easy. Just copy the original in parentheses. The hard part is this one, f of x plus h. So we've done some exercises with this already. Right here, pretend you erase the x, put parentheses, x plus h, right? So this mess right here is f of x plus h. 3 parentheses, x plus h, replace x with x plus h, minus the 2. Minus the original f of x, so minus parentheses, 3x minus 2, and divide the whole thing by h. Okay, now clean up the algebra. 3x plus 3h minus 2 minus 3x minus a minus 2 plus 2. And very conveniently, these cancel out. These cancel out. I just have 3h over h, which is 3. So the answer to C is 3. And for this particular case,
really quick in the homework, like it's like stepping stones, you know what I mean? So like when it came to C, I just used the previous answers. That's cool. I don't have to redo it. You don't want us to like redo the entire problem, do you?
You don't have to redo the entire problem. No. But I am, yeah. I'm letting you go straight to C, in other words, because C includes A and B. And this is what you're going to be doing in calculus, to be honest with you. In calculus, you would jump straight to this expression.
I'd also appreciate going over a couple of these because when it came to like the answer of C becoming a fraction, I really didn't know what to do with D.
I'll show you another one.
Okay.
I was going to show you 43 also.
Yay. Okay.
All right. D here it says h approaches 0. That's irrelevant here because my expression doesn't involve h. So it's almost like hold the thought for C. Now, the next one I was going to show you is 43. There is an h in this expression for 43. Here it doesn't apply. So the answer is still going to be 3. It's almost like this is irrelevant. It's like saying, okay, what's the answer to this problem if today is Friday? Today is Friday is completely irrelevant, right? It doesn't matter. Or what's the answer to this problem if this is the month of August, right? It doesn't apply. The answer is still going to be 3, right? So there's nothing to plug in. But the next problem, it definitely does apply. So I'll show you that.
Is that because the formula
also? Okay, so 43 f of x equals 1 over x.
That formula.
Yeah, let me finish what I was going to say. F of x equals 1 over x is the next problem that I was going to show you, and I'll establish what happens because there is going to be an h there. Yeah, go ahead, take a question now.
Yeah, so basically on the problem right here, when we first on C, the final result is 3, right?
Correct.
On C, okay, but on D, my understanding that in this formula, when we got f of x plus h minus f of x over h, technically speaking, that's when it approached 0, but never touched 0, correct?
H approaches 0, correct.
Okay,
but this
so
expression doesn't, there is no h. So it's irrelevant.
That is correct. So we just got 3.
It stays 3. Okay. It's almost like saying,
so
if h approaches 0, what happens to 3? You don't care. It's like saying, what happens to 3 if this is August? What happens to 3 if this is 2021? It doesn't matter. It's still 3. Okay. I think it's better if I go ahead and do. I think it's better if I go ahead and do 43 because that will answer the question about this h. In case you're still puzzled about that, it doesn't apply here. Okay.
Okay.
Yeah. So let me go ahead with 43. F of x equals 1 over h. Now here, the answer to part C is going to involve an h. All right, so f of x equals 1 over x. F of x plus h minus f of x all over h. Okay, so there's an h on the bottom minus the original f of x. So the original f of x is 1 over x. Now, f of x plus h. Pretend you erase this x, replace it with x plus h. So it's going to look like this. So this junk right over here is 1 over x plus h minus 1 over x, all divided by h, like so. So this is my expression, except we normally don't want to leave it like that because that's way too messy. Okay. So I need to make this a little bit better. So here's what we're going to do. I'm dividing by h, which is like h over 1. If you divide by a fraction, you multiply by the reciprocal. So I'm going to write a multiplication by 1 over h instead. That makes it a little bit better. So it looks a little bit cleaner because we don't like have a fraction on top of a fraction. So I'm dividing by h over 1 is the same thing as multiplying by 1 over h. Okay. And now I have that minus that. So cover this up. 1 over x plus h minus 1 over x. Okay. And now I need a common denominator. So multiply this side by x over x. Multiply this side by x plus h over x plus h. Okay. By analogy, in arithmetic, how do I do 1 over 7 minus 1 over 5, right? Well, you multiply this side by 5 over 5, multiply this side by 7 over 7. So it's the same principle. It was over here. So this fraction I multiply by x over x. Multiply this one by x plus h over x plus h. Which means my common denominator is now x times x plus h, right? That times that. That's just like over here. The common denominator is 7 times 5, 35. Common denominator is x times x plus h. Okay, so I work out the top. 1 times x is x minus parentheses x plus h. You can ignore the 1, right? Because 1 times that is that. So it's minus parentheses x plus h. So it's minus x minus h. Well, x minus x cancels out. So on top, I have a negative h. On the bottom, I have h, x, and x plus h. Well, I can cancel these h's. So I now have negative 1 over x times x plus h. So that's the answer to C. Now this expression has an h, which was not true over here. All the h's canceled out. I just had 3. So now part D is meaningful. It says, what's the value of this mess as h approaches 0? So the arrow means approaches. You'll be seeing that symbol a lot in calculus. H approaches 0. So when h gets really, 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 really small, gets close to 0, 0.1, 0.01, 0.001, 0.001, 0.001, you pretty much just ignore this. Okay. In actuality, when you work this problem out, just plug in 0. If I plug in 0, I have negative 1 over x times x. So see here, I have x times x plus h. Just plug in 0. So the final answer becomes negative 1 over x squared. And that's about it for that one. Okay. Right, so that's how to do that. And let's see, yeah, quick review. I think I already went over this, but I want to remind you of even and odd functions. And put this on your cheat sheet for the test next Friday, if you wish. A function is even if f of negative x equals f of x for all x. It means you have y-axis symmetry. And a good example is y equals x squared, which is part of the reason why it's called even. Y equals x squared. That might lead you to believe that that means x to the 4th, x to the 6th, 8, 10 are also even, and yes, they are. Okay, but those are not the only even functions. So strictly speaking, there are even functions that don't look like x to the 2, 4, 6, 8, 10. Okay, we follow the definition right here. Okay, an example of an even function which doesn't look like this is the cosine function. Okay, from trigonometry, the cosine of negative an angle is the same as the cosine of an angle. So the cosine function is even though you don't see any even exponent. Okay, so like the cosine of negative 17 degrees and the cosine of positive 17 degrees are the same thing. So by definition, you have an even function. And you have an odd function. A function is called odd if f of negative x is negative f of x, the opposite of f of x for all x. Okay? And that means you have symmetry with respect to the origin. So a good example is y equals x cubed, which incidentally is an odd exponent. Okay, so if I replace x with negative x, right, put negative x right there, what is negative x cubed? Negative x times negative x times negative x is negative x cubed. That's exactly the opposite of what I start off with. So that tells me I have origin symmetry. And as you might guess, x to the 3rd, 5, 7, 9, 11, those are also odd. But again, if you go straight to the definition, there are some functions that are odd that don't look like, something like this. And one example from trig is the sine function. The sine is an odd function because the sine of negative x is the opposite, the negative of sine of x. So if you were to punch in your calculator sine of, I don't know, sine of negative 21, and you hit the sine of positive 21, they'd be exact opposites of each other, okay, which tells you that you have something called an odd function. Okay, so that takes care of that. Let me see. Set you up with some of these other problems at the end. Okay, a rectangle is an area of 64 meters squared. Express the perimeter of the rectangle as a function of the length s of one of the sides. So some of these word problems at the end. Let me set you up with those. Okay, area is 64. I know it's x times y. So area is length times width, x times y, 64. If I divide both sides by x, I have y equals 64 over x. Right, so my dimensions are x by 64 over x. And now I want the perimeter. So how do I find the perimeter of a rectangle? It's 2L plus 2W. So 2 of these, 2x, plus 2 of these, 64 over x. So 2L plus 2W, 2x plus 2 times 64 over x. So 2x plus 128 over x. That's sort of the answer. They do say to use the letter S. Okay, I thought it would be better to just use x itself, but strictly speaking, if we wanted to answer the question, P of S is 2S plus 128 over S. So that officially tells you how to do that. Okay, then let's see, how much time do we have left? A few minutes. 63. Express the surface area S of a cube as a function of its volume. You're given the volume, how do you find the surface area? You're given a cube. The formula for the volume of a cube with a side of x is x cubed. Right? So all the sides are the same, x by x by x. Volume is length times width times height. But if you have a cube, they're all the same. So volume is x cubed. Solve for x, take the cube root. Cube root, cube root. So x is the cube root of v. And now it asks for the surface area. So if I have a cube, I have 6 faces, right? There's a front and the back, left and the right, top and the bottom. They all look the same. They're all squares, right? Can you see the front's a square, the back's a square, the left and the right are squares, the top and the bottom are squares. How do I find the area of a square? That would just be x squared. Okay, so S of V, S meaning surface area, if we're given a V, is 6 times x squared. Okay, so one of these areas is x squared. There's 6 of them, front and back, left and right, top and bottom. So 6 of these squared, 6 radical V squared, which I can write as 6 times the cube root of V squared. So this would be the answer. S of V is 6 times cube root of V squared. Or you can write it like this if you wish. This is acceptable, but this is also acceptable. 6 V to the 2/3 power. There's a way to write the answer for that one too.
Or 6 parentheses cube root V and parentheses squared, right?
Like this,
Yeah.
or if you put parentheses, it's fine, but you don't really need the parentheses. You can just write it like that. So that works also. That's fine. Okay, so that's those. I want to give you as many as possible before the weekend so you can see how these things work. Let's see. Yeah, 67 was kind of messy. And I might have to just stop with that one, but we'll see. 67, a manufacturer estimates the profit is P of X is 300X minus 2X squared. And then all this stuff again, average rate of change as we go from X to X plus H. And then you plug in some stuff. Okay. And let's see. Let's not worry about the sketch. I'm going to skip D.
I was having trouble, I was on it with the tutors too. So like, basically on a bunch of them, it wants us to find, like on 69, it wants us to find, I think it was the, what was it? It was the minimum or the maximum. And it wasn't like our equations, like, they're not really, it's not really in, standard form. So like they didn't really know how to approach it with me because like I'm in pre-calculus, but I'm not exactly calculus, so they couldn't approach it like calculus wise, you know what I mean? They didn't know.
Yeah, so you basically had a quadratic, I believe. So you would have to use a quadratic expression and find the vertex. And if I have time, I'll show you how to do that. Yeah, I'm not sure I'll get to 69 today, but we'll see. Okay, so let me set you up with 67 at least. So they give you this. Okay, average change from x to x plus h. Okay, so it's basically a slope. y2 minus y1 divided by x2 minus x1 is the average rate of change. So p of x plus h minus p of x divided by x plus h minus x. It's slope. So when it says average rate of change, you want y2 minus y1 divided by x2 minus x1. Let me do the bottom first. What's x plus h minus x? Well, that's just going to be h. The top is a mess. It's p of x plus h minus p of x. Well, the original p of x is just this, 300x minus 2x squared. But p of x plus h, well, put x plus h right there, put x plus h right there. So 300 parentheses x plus h minus 2 parentheses x plus h squared. And that kind of looks like the stuff we did earlier, right? Those earlier problems. Whoops. All right, now some heavy duty algebra. So distribute 300x plus 300h minus 2, and then x plus h squared, x squared plus 2xh plus h squared. Distribute, distribute. So minus 300x plus 2x squared. And now I distribute the negative 2, 300x plus 300h minus 2x squared minus 4xh minus 2h squared minus 300x plus 2x squared all over h. Okay, so all of that, these two here cancel out. These two cancel out. So I have this one, and this one. And these three have a common factor of h. If I pull out the h parentheses, that'll be 300 minus 4x minus 2h divided by the h in the bottom. And then these two cancel out. Leaving me with 300 minus 4x minus 2h. Now, B, average rate of change from 25 to 50. It's much easier when you plug in numbers, as you can tell, rather than all this x and h stuff. So average rate of change from 25 to 50, I find P of 50, P of 25, divided by 50 minus 25. Okay, so that means P of 50, plug in 50 right here. I'll just tell you what it comes out to be. You can punch this in as well as I can, or even better. Put a 50 there and a 50 there. It comes out to be, whoops, 10,000. Do the same thing for 25. Plug in 25 right there, 25 right there, grind it out. Comes out to be 6250. And divided by 50 minus 25 is 25. So 3750 divided by 25 is 150. So the answer is 150. Okay. Now, yeah, we're not going to worry about the graph. So let's skip D. I said 67D, skip. 67D, skip. Instantaneous rate of change. Instantaneous rate of change when 25 units are produced. I take this expression 300 minus 4x minus 2h. It said to plug in what? 25. And you plug in 0 for h. So h is 0 for instantaneous rate of change. At this stage of the game, you plug in 0 for h. So 0 goes there, 25 goes there. 300 minus 4 times 25 minus nothing, which is 300 minus 100 or 200. So the answer is 200 there. Okay, and I see we're just about out of time. Let me check the chat if anybody has anything. Only a few minutes left. Okay, I have maybe 2 or 3 minutes for a question. Anybody want to ask a quick question? So you've got your quiz to work on. Turn it in by 11:59 tonight, and I've told you how to do it. So hopefully it's not too bad. So Monday I'll finish up section 6 and continue on with section 7.
Is your office hour on this? Do I just stay after class on this Zoom?
It's not in the Zoom. There was a separate Zoom link for office hours.
Can you?
I've given that to you before.
Is it in your? Is it in the syllabus?
It's in the syllabus, or if worse comes to worse, you send me an email, and I can email you back what it was. But yeah, the syllabus, I sent the link for office hours a couple of times, I'm sure.
Are you having office hours today?
Monday through Friday from 10 to 11, and some days beyond that by appointment.
Yeah, I don't see it. I guess I'll email you and you'll email me right back.
Yeah,
I'll email you right now, okay?
Sure.
And how can I determine on Sunday your hours? Like
office hours? Yeah, it was on the syllabus, but it's 10 to 11 Monday through Friday. And
no, but I'm
some
talking
other hours
on,
by appointment. If you need the link, send me an email. I sent that out even before class started, like 1.5 or 2 weeks.
I think it's in the syllabus.
Yeah, it's in the syllabus. Oh no, the links are not in the syllabus. I sent you the link.
No, you sent an email.
I'm sorry, I didn't understand your question.
I think you sent an email with all the hours using the same.
Yeah,
which
I
is
sent
what
it at least twice, maybe 3 times.
Yeah. So is that email the same for the office hours?
Correct. It's not the same as this Zoom link here from 9 to 10. It's a separate link.
Daily, I'm looking right now as we speak. It says, let me see, meeting ID. Okay, I'll look into the same email, right?
Yes, it should be the same email. Or if worse comes to worse, send me
Yeah,
another email. I can email you back with the link.
I'm looking at it right now. If I think David's talking. If you look at the email that has the download for the syllabus, you'll scroll down and then you'll see the Zoom link for class. And then after that, you'll see the Zoom link for the for his office hours.
Yeah, you have to scroll further down.
Yeah, it's there. Yeah.
Got it.
Okay.
Thank you.
All right, you're welcome. 9:59. Any quick last questions, please? Otherwise,
my last question is within the quiz. On first question, all you need is the formula, right?
I'm sorry, could you say it again?
On quiz number 2, the first question, you just want the formula?
You just plug in for the equation of the center and radius. It's pretty much just a plug-in.
Yeah. But I mean, that's basically what we need to do.
That's it. Yeah, there's really no work for question 1.
Yeah,
you pretty much just write it down.
Yeah, and for letter number 3, when we talk about the symmetry, you want us to do the test?
You do all 3 tests. Yeah, just as I explained.
So you want us to do the test and the graph, right?
You don't need a graph. You may have a graph, but you don't have to.
Okay, just the test.
Yeah, do the 3 tests.
If it's even, odd, and stuff like that. Got it. Okay.
All right. I see it's 10 o'clock, folks. So have a good weekend. Turn in the quiz by 11:59, and we'll see you then. Okay. All right. Bye, everybody. Have a nice weekend.
You too. Bye-bye.